Thank you for joining us for this CEGE Connects lunchtime seminar series. There's really a lot of amazing and creative research that is happening in the Civil, Environmental, and Geodetic Engineering department right now. And the value and impact of that work is only fully realized when it's informing practice or policy. This CEGE Connects seminar is an opportunity to hear from faculty of their perspectives on recent innovations that are relevant to practitioners. We're happy to reconnect with you today and to highlight that the CEGE department can serve as a resource in the work that you continue to do. It's my pleasure today to introduce Dr. Andre Carrel, who is an interdisciplinary expert who interprets data analytics, behavioral science to understand rider response to emerging transit options. He holds an appointment with the Translational Data Analytics Institute here at Ohio State, and he also has a joint appointment with the Division of City and Regional Planning that's in the Knowlton School of Architecture. I will share just one brief highlight that Dr. Carrel has been recognized with one of the prestigious grants through the National Science Foundation Early Career Program. So congratulations, Andre. And I'll ask that participants please drop questions in the chat function at any time during the presentation. I will moderate those in the question and answer session at the end of Dr. Carrel's presentation. And we will follow up with those of you who are interested to receive continuing professional development credit with a certificate in about 2 weeks after the presentation. So with no further introduction, let us now welcome Dr. Carrel.
Thank you very much. It's a pleasure to be here. So I'll go ahead and share my screen, my presentation slides. All right. Kevin, is this everything visible here?
That's great, Dr. Carrel. Thank you, sir.
Okay, excellent. So hello, everyone. It's great to have you here in this lunchtime seminar. As Dr. McKay said, I'm a professor of transportation with a main focus on travel behavior. And what I plan to talk about today is about two technologies that promise to improve the sustainability of urban transportation. And I'm going to present the results of two recent research studies that we've conducted here at Ohio State University. So all right. So the general motivation here is that improving the sustainability of our transportation system really is critical. The transportation sector is the largest source of greenhouse gas emissions in the United States. And so if we want to reach achieve sustainability goals, we really need to think about how to reduce those emissions. Now, here you can see this graph that shows the emissions of various sectors in the US from 1990 to 2020. Transportation is the green line here. Now, as you can see, it is currently the largest source of greenhouse gas emissions, in part due to the recent declines in emissions from power generation. So this reflects the increasing prevalence of renewable energy sources. We have a bit of a dip here at the end from 2019 to 2020. The reason there, of course, is the pandemic and the travel restrictions during the pandemic. So this is not the more recent statistics are not out yet, but I would certainly expect that there's going to be a rebound here, and that we're not going to see a permanent dip in the emissions from the transportation sector as it appears on this graph. So that brings us to the question of how we can reduce emissions in the transportation sector. Now, there are many different dimensions here. There are many different approaches that we can take. So one of those is, of course, changing travel behavior, right? Every day we make decisions about where we're going to travel, how we're going to travel there. Some of the trips that we make are what we call mandatory trips. So things like commuting to work or commuting to school. This is the type of travel that is relatively not very negotiable. And then there's also travel that is what we call discretionary. So travel for leisure purposes, for shopping purposes, and that tends to be more flexible. So we can make decisions as to where we drive, when we do so, whether we drive during congested hours or not. So overall, when we talk about changing travel behavior, there are many different dimensions here. We can talk about examples of what we might investigate is how we can reduce driving distances, how we can reduce discretionary travel by car, increase carpooling, increase transit use, or also something that is a bit of a more recent development, incentivize people to use on-demand pooled transportation services where multiple trips are pooled with one and served simultaneously with one vehicle. And therefore, we only have the emissions due to that one vehicle trip, but it's serving multiple passenger trips. Then, of course, there is another large area that has been discussed a lot recently, and actually the Biden administration has just been pushing or just pushed a large package of legislation to really increase the adoption and production of electric vehicles. So this is generally the concept of electrification of the transportation system. We might talk in this context about electrification of privately owned vehicles or also electrification of shared vehicles. And then lastly, I don't want to forget to mention that these are more direct things that we can do. We can look at changing travel behavior, we can look at electrification, but really also a lot of our travel behavior is driven by the way that our cities are designed. And so in the long term, changes in urban design can also really have indirect impacts on the travel choices that people make. So if we work on increasing the density of our cities, which I mean, for example, that more destinations are reachable by walking, then we can also reduce vehicle miles traveled. If we increase the mixed use areas within our cities, that means that opportunities such as shopping or even employment opportunities on average might be closer to where people live. And so that again, that would come with potential reductions in vehicle miles traveled and vehicle trips. Even if someone takes the car, they might be driving shorter distances to reach things. And then of course, if we're talking about changes in urban design, we also need to think about infrastructure for sustainable modes. Many cities in the United States are designed in a very car-centric manner. So if we could introduce more pedestrian infrastructure, bicycle infrastructure, public transportation infrastructure, then that would also incentivize and support the use of these modes of transportation. Okay. Right. So what I'll talk about next are two studies that address 2 points within this list. So the first one is this point here about on-demand pooled transportation. And the study that we conducted, and this is the first one I'm going to talk about, is a study here at Ohio State about the potential demand for a microtransit system. So I'm going to explain what I mean by that, what's a microtransit system, and I'll discuss how we conducted this study, what the outcomes were, and then what the bigger takeaways are from the results that we got. And then after that, I'm going to switch gears, and I'm going to talk about a second study that we also conducted in recent years, which was on the adoption of battery electric vehicles. So battery electric vehicles, we're thinking about vehicles like Teslas or the Ford Mach-E, which are fully electric. They only run on battery power. There's no combustion engine on board. And so here again, I'm going to go over the study that we conducted and discuss some implications and takeaways for policymaking on how we can actually help improve the demand for such vehicles. So with that, I'll move on to part one about assessing the potential demand for an on-demand microtransit system. So first, let me introduce microtransit systems. As the name says, this is right, that the word transit is in it. Generally, what we understand under microtransit systems are public transportation systems, or publicly accessible transportation systems, although I'm going to define in a moment what we really mean with publicly accessible, that are typically carried out with smaller vehicles than the typical normal size buses that we tend to see on our in our transit systems, such as CODA. Now, the problem that this is trying to solve is that fixed route public transport works best in high density walkable environments, right? High density walkable environments, that there are two effects here. One is that it is easier for people to actually reach a bus stop, to walk to a bus stop, right? And the second thing is that sufficient in higher density environments, we reach kind of a critical level, critical number of people living in the vicinity of bus stops or transit stops, subway or light rail stops, such that the system can serve sufficient number of trips and therefore is economically viable. Now, many cities in the US, of course, are heavily auto dependent. And in Columbus, we do have a denser downtown area. We have a denser core of the city. I'm thinking about areas like the Short North or downtown Columbus, the campus area, Old North, of this, the older parts of Columbus. But once we head out into the suburbs, think of like Hilliard or Westerville, very quickly the density becomes fairly low. And so that's a much more auto-dependent environment. So those are environments where public transportation, the fixed route, typical public transportation systems are not super competitive. And new on-demand modes of transportation are trying to fill these gaps where fixed route transportation is not really a very competitive option. So one such mode is microtransit. And as a matter of fact, CODA, our local public transportation operator, has been operating a microtransit system for the last few years. It's called CODA Plus. Here's a picture of one such vehicle. So that's an example of a public microtransit system. Like I said, it operates with smaller vehicles and it provides point-to-point transportation. So if you want to make a trip, then you have an app, CODA app, which you use to order a vehicle, basically to reserve a trip. You get told where the vehicle is going to pick you up and when it's going to pick you up. And when it does so, then you get on board and you travel to your destination on board that vehicle. Now, typically, it will also make additional pickups or drop-offs while you're en route to your destination. So you're sharing the vehicle with other customers. There's also another version of this kind of system, which is a private microtransit system. So these are typically, we call these employer-sponsored systems, which is the case where large major employers who have many, many employees will sponsor a system that is only available to their employees. So for a while, JP Morgan Chase here in Columbus was doing that. They have since discontinued it. But you can also think of, say, the tech buses, the Google buses in the San Francisco Bay Area, in case you've heard of those. Those would be a larger version of these kinds of systems. Now, fairly little is known about what drives people to take such a microtransit system, both in the public and the private context. Now, in our case, we were specifically interested in the variables that might drive people to use an employer-sponsored microtransit system studied in the Columbus context, right, which is a fairly auto-dependent context, all things considered. So we designed a study to shed some light on this. Okay, so the location of our study was actually here at Ohio State. The purpose of it was to, as I noted, to understand the potential demand for commuter service, and we applied this to the OSU Wexner Medical Center. We were looking specifically at OSU Wexner Medical Center employees. The Wexner Medical Center is a very large organization. So we have 7 hospitals in total in the Columbus area. There will soon be more. And about 100+ buildings in the greater Columbus area that in one way or another are connected to the Wexner Medical Center. So now the main part of its operations are here on Ohio State's central campus. And anecdotally, congestion and parking around core campus is a major source of stress for medical center employees. The nurses union has been very vocal about their unhappiness with the transportation parking situation in the around core campus. And anecdotally, we've also heard that from other job functions, from physicians, for example. So now we're expecting that these congestion problems are actually going to increase in future years because even though a little bit of parking capacity is being added, the Wexford Medical Center is currently constructing additional hospitals that are going to further increase commute traffic and patient traffic for that matter. These problems tend to be fairly concentrated here on the OSU Central Campus. So off-campus locations, think of outpatient clinics all around Columbus, they tend not to report these kinds of issues. So here's a brief overview. Here we have a map on the right-hand side of the OSU core campus. So this is the core campus. You can see the horseshoe where the third blue star is on the map. And then in the red box below, we have the Wexford Medical Center, the medical campus. So there are several parking garages around the medical center. They're marked here with red stars. Now these parking garages, they get very congested. They're typically primarily reserved for patients and for faculty and physicians. Parking passes are very expensive. They are $1,160 a year, at least they were at the time when we conducted the study. The other staff, so the medical center has, depending on how you count, part-time appointments, somewhere between 20 and 30,000 employees. And so all these people in one way or another have to commute to their work location. So many staff members of the medical center, they park at satellite parking lots. So those are marked with yellow stars here. And then they take a park and ride bus service to the medical campus. There's a central drop-off point at a transit hub, Herrick Drive Transit Hub, it's the yellow bus there. It's a high frequency service. If you park out here, then you have much cheaper parking pass. It's $150 to $300 a year. But even though it's a high frequency service, it does tend to add about 13 minutes of travel time from the outlying areas from those satellite parking lots to the medical center. So it does add a non-negligible amount of time to your commute. Now, other OSU parking lots that are not specifically for the medical center, those are marked with the blue stars here. They are within 10 to 20 minutes of walk to the medical campus. Parking passes there somewhere between $150 and $1,000 a year. What's marked down here in green are the new hospitals that are under construction. Now, given this situation, we have many people who are parking at those satellite parking lots. We have a smaller group of employees that parks at the central campus locations. They complain about very high levels of congestion, difficulty finding parking, and people who have to take the park and ride service do tend, some groups tend to be somewhat vocal about the fact that they're having to do this, that they have to park that far out and take the shuttle service in. So we wanted to look at the potential demand for microtransit service. Here are the parameters of such a service. We specifically described it to the participants like this. It would be a private commuter shuttle. It would be reserved only for Wexford Medical Center employees. Every shuttle would have 14 passenger capacity, would be equipped with Wi-Fi, and have professional drivers. The employees can commute to and from the building of their choice using this service. To commute to work, they would have an app. They would indicate a desired arrival time at work, and then they would reserve a spot on a microtransit shuttle that would get them there, would be guaranteed to get them there before that time that they have to be at work. They would be assigned a pickup time and a pickup point. The pickup point could be at their home or near their home. And then the routes and schedules would be created on the fly to guarantee that they would arrive at or before the requested time. And if they wanted to commute home, they'd repeat the process. So they would have potential wait time before when they arrive, before their actual workday starts, depending on when the shuttle arrives. And they potentially would have to wait a little bit at work before they would catch their shuttle ride home. So the method with which we studied this, it was a survey. This was all survey-based because, of course, this is a hypothetical service that doesn't exist. It's called a stated preference survey. It included what's called what's a choice experiment. This is a very typical thing to do in behavioral and economic research. I'll describe in a moment what it is. So the main research question here was to understand under what circumstances commuters would choose to travel by the microtransit service rather than their personal car. And we really designed it around the actual characteristics of their car commute. We conducted this online survey by sending out invitations online to OSU Wexner Medical Center employees in February and March 2020. So in hindsight, we got extremely lucky because our survey was just closing in early March 2020 when the pandemic hit and when all the major shutdowns happened and people's travel patterns got disrupted. Overall, we ended up with 955 valid responses from medical center employees. We collected their demographic information, information on their current mode choice, although we ended up only analyzing people traveling by car, and their current commute patterns. And then we did a stated choice experiment. I'll describe that in a second. And after that, we also asked them a series of questions on other factors that might affect their choice to use the microtransit service or not. So what's a stated choice experiment? So I said, we asked people information about their current commute. So we asked them to tell us a little bit about their driving time, the time it took them to find parking, any costs that they incurred, whether they made stops or not, etc. And so we then constructed an experiment where in the survey, people were given a hypothetical choice. So it said, given this scenario, which option would you have chosen for your recent commute? So we specifically asked them to focus on a recent trip that they made, a very recent commute. And we said, here at the bottom, this is what you told us was the times and costs of your commute by car. You drove for 15 minutes, it took you 5 minutes to find parking, it took you 23 minutes from the moment you got out of your car till you walked through the door of the hospital. So in total, that adds up to 43 minutes door to door. And then the estimated cost per day, $7.46. This includes cost for gasoline maintenance, basically per mile cost, plus the cost of parking. And then so this is what you actually, as a respondent, revealed that you experienced. And now we said, well, imagine that you had this hypothetical commuter shuttle available to you. The shuttle would have the following characteristics. It would, in this case, so this screenshot that we're showing, in this case, it would pick you up at home. So 0 minutes to get to the shuttle stop. You'd be on board for 24 minutes, but then you might arrive at your destination somewhere between 0 and 30 minutes before the time at which you really want to arrive. And it's going to be the same thing when you want to leave. Up to 30 minutes, you have to wait at the hospital until you can catch your ride home. And the cost of this is going to be $4 per day. Now, these attributes of the service, these are things that we vary. So by doing this, by playing with the attributes and reducing the travel time or increasing it, placing the shuttle stop at your home, hypothetically, or somewhere else, by changing the cost, by varying these things, we can understand what the trade-offs are that people make. And what really drives their choice between the shuttle and the car. So each of these scenarios, people are asked to make a choice. Which one would you choose if you were making a choice under these circumstances, right? And by looking at the pattern with which people make the choices, we can make inferences by applying statistical, what are called discrete choice models, to analyze the trade-offs that people make and understand what the drivers are of these decisions. So I'm going to go ahead and talk about the overall results. First, I'm going to talk about what we found about designing this kind of a service. And then after that, I'm going to talk about some other factors, including the demographics of potential users. So we were actually really surprised. And we are aware that similar employer-sponsored services have actually had considerable difficulty elsewhere in the country and here in Columbus, for that matter, attracting sufficient ridership. Now, when we performed this study here at the Wexner Medical Center, we found a considerable interest in the service. So on average, overall, approximately a third, roughly 30% of the surveyed employees actually indicated that under certain circumstances, they would try and use this microtransit service. Now, individual demand, so what really would make people opt for the microtransit system, that really depends a lot on the design of the system. So what I have down here, these four next points refer the individual design variables that we varied up here and that we presented to people and then asked them to make choices based on those. So first, and perhaps not surprisingly, the travel times relative to the automobile, of course, are important. So if your microtransit commuter service is going to take you much, much longer to get to work than by car, you'll be more likely to use the car. That makes sense. And that would be an expected result. We did find that. However, what we were not expecting is that on average, looking at all our respondents, we actually found that they considered the travel time on board the microtransit service to be more than travel time in their car. The way that we see that is if we make comparisons by all else equal, what is the equivalent, what is the travel time by microtransit and by car that would make them indifferent between the two options? And as a matter of fact, turned out that there was about a 28% difference. So about 28% people would be willing to accept about 28% more travel time on board the microtransit shuttle compared to the car and would still consider it to be equivalent. So we think this can reflect a few things. Our hypothesis is that primarily this is probably reflecting commute stress and the fact that if you are on board of such a shuttle with a professional driver, you're not experiencing commute stress due to congestion and also due to potentially having to find parking and take a park and ride shuttle. Then we looked at the pickup and drop off location at or near people's home. And as a matter of fact, perhaps intuitively, we did find a difference here, but quite a significant one. So having a designated stop that you had to go to, you had to travel to that stop, maybe at a parking lot of a mall, you'd have to drive there, you'd have to walk there. Immediately, the share of people who'd be willing to take a microtransit service under those circumstances dropped to about 22% on average. If people were picked up at their homes, we're looking at more of a 35, so a little over a third of all commuters being interested in taking the service. If we think about trade-offs, respondents on average said they would need to save about 12 minutes or $2.76 overall on their trip to compensate for the inconvenience of not being picked up at home. Now, why is this important? If we want to try and pick up people at home, it makes the planning of the routes of these kinds of services a lot more challenging. And it also adds travel time for everyone, right? If I'm trying to pick up everyone at their doorstep, then my microtransit shuttle is going to be making a lot of detours through neighborhood roads going to pick up people. If we can get people to go to some sort of central pickup location or shuttle stop, then that's going to drastically reduce the amount of travel time that they have on board. But as we can see, obviously, it's also going to considerably reduce the number of people actually willing to try that service compared to taking their car. Conversely, if we look at the wait time window, right, I indicated beforehand in the example I showed that 30-minute time window before and after work. Now, that did not actually, interestingly, have a huge impact. So an additional 3-minute wait window seemed to reduce ridership by roughly 3%. So really not a huge impact there. We suspect that that might be because the hospital does tend to be a lot of employees at the hospital work shifts, and work times tend to be fairly well delineated, and it makes it easy for you to plan around these sorts of shuttle schedules. So this might look different with other types of employers. Lastly, the cost of the service has a very large impact. If we're going to charge, now I have two fair points. We did have a larger range that we asked about, but just to show you the magnitude of impact, a fare of $4 a day would give us at roughly 1/3 a share of commute trips that would be served. But if we double that up to $8 a day, then we're dropping down to a little over 10%. So a pretty severe impact there. Now, of course, the issue here is microtransit running this kind of a service is not free. And the question for the employer, for someone like the Wexner Medical Center, is how much money is the employer willing to contribute to offer this kind of a service to their employees? And obviously, this can be seen as a benefit that is being given to employees, right? And some employers make it free. Some of them will have fully subsidized service. You don't have to pay anything, just get on board. But but others might be a little more concerned about the cost and might want to charge something. So there is a serious consideration here that the employer has to make, and it will really affect the number of people who will opt to use the service. We also had a scenario, I want to note this quickly, where we looked at the reliability of the service. And we did find that the reliability is incredibly important. Now, why this is particularly important in the context of designing such a service is that oftentimes when people implement these kinds of services, they try to start out small. Few vehicles, let's see how people react, let's see what kind of interest we get. The problem is, we showed people a scenario where we said, imagine you tried to reserve a seat on a shuttle, but you're told it's full and you should try again tomorrow. So first bullet here. And it turns out, as a matter of fact, one such experience at the beginning, which is very likely to happen if we're starting the service small, that leads to very serious drops in ridership. So depending on the characteristics of the respondent, about 35 to 60% would be unwilling to try the service again a second time. Even among those with the strongest interest in regularly using one, 20 to 40% said, if this happens once, I'm not willing to come back and try it again. So here's an implication for service design, like I was saying, right? Starting small strategy with a few vehicles, but that might be longer wait times and sometimes people might be bumped from rides, might not be a very good strategy when implementing these kinds of systems. And we really want to investigate in the future, someone who wants to implement this kind of system should investigate strategies to mitigate the impacts of occasional reliability problems, like pay people to take an Uber instead, or make the next trip free, something to get them back. So lastly, I want to talk about other possible drivers here. Interestingly, the interest in the service was relatively independent of sociodemographics. We wouldn't have expected this, but across all job groups, all income levels, all age groups, you're traveling with colleagues from the Wexner Medical Center. The impact of who the respondent was actually very, very limited. On the other hand, having experienced congestion at parking garages really drove interest in microtransit. We asked people about a few other concerns that they might have. Here's a key one, probably the most important concern, was the ability to get home in an emergency situation. What do I do if I don't have my car? Now, there are solutions to this. Emergency ride home programs, for example. And then we also found that the customer base that we were talking about, the people who really were interested in using this service, many of them would want to use this time productively. So about 50% of the people said they would want to work during their commute, which means that having good Wi-Fi on board and a quiet working environment would likely incentivize them to ride. However, with that said, turns out that people who said they wanted to socialize on board, so have coffee with their colleagues and talk, that the willingness to socialize actually had the largest association with someone's willingness to try the service. So these are purposes that are kind of at odds here, right? And so going forward, what we're envisioning as a next step in this research is to look at, would it be possible to provide different types of services for different passenger types? I mean, basically have a quiet van where you can work, you've got Wi-Fi, and then have a van that is more aimed at those that actually want to socialize and have their coffee and talk to their colleagues. Also a frequent rider program, use it for 10 days, get one free, and a potential offering for snack and coffee on board would really increase interest, but only among those that are already interested. So those who are unwilling to try the service, so such incentives didn't have much of an effect. Finally, we wondered whether microtransit would be some way of reducing car ownership. And the answer does seem to be no. So only about 8% said if they were using this for all their commutes, they would reduce the number of cars in their household. So really, while this can reduce vehicle miles traveled for commute travel, it doesn't seem to be a good strategy for reducing car ownership in general. So let me talk a few minutes about lessons for Columbus. Now, we looked at the Wexner Medical Center. There's another big development that's happening right now, and there's been a lot of talk about this in recent months, which is the Intel site that's moving to the construction of the Intel factory around New Albany. So this is going to be a relatively low density area. And we're already envisioning that there's going to be additional commute traffic on routes 161 and I-270. there is a bit of a concern given the location that this of Intel that Intel has chosen, that it might drive further urban sprawl. Business parks or residential developments in relatively low density areas. So this is unlikely to be an area that is really suitable for fixed route transit. This would be a very good opportunity to invest in employer-sponsored microtransit systems to reduce commute travel to and from this location, to Intel's location, as well as other businesses that would choose to locate there. The other advantage of doing this, of adding microtransit service here, would be to significantly improve opportunities at Intel for lower income and marginalized populations in the Columbus area. Because the areas that, the place where Intel is building the site, it's not terribly accessible in general. And it's also surrounded by New Albany, which is a fairly high income area. Lower income marginalized populations might have difficulty accessing jobs there due to limited access to automobiles and long commutes. Microtransit service would be a very good way to address some of these problems, some of these barriers. Okay, so with this, I'm going to move on, and I'm going to talk about I'm going to skip to the second part, which is talking about battery electric vehicles. So one other way to increase the sustainability of our transportation system. I'm going to talk about a study about the decision to adopt a battery electric vehicle and how that's affected by regional differences in energy production mix. So, like I said at the beginning, battery electric vehicle, we're talking about cars that are solely powered by battery, and you need to plug them in order to charge them, right? Think of your Teslas, your Ford Mach-E's, your Chevy Bolts. So, battery electric vehicles obviously are a very good way to reduce emissions associated with transportation. They're part of a broader change that's needed to shift reliance away from fossil fuels. However, market shares are currently pretty low in most countries, and consumers still have a lot of hesitations about adopting BEVs, battery electric vehicles. So down here, you can see this is up to only 2018, unfortunately. But you can still see the relatively low market shares in most markets around the country, most major markets around the globe. China has, if you look on the right-hand side here, had about 4.5% of market share of electric vehicles among new vehicles. The US and Europe are just below 3% here, although there are, of course, large regional variations. So the front runner in Europe is Norway, thanks to very generous subsidies. They're about 46%, a very high rate. In the US, I think we're about 10% is the highest state. I think that's California. So there are very large regional differences here. Now, if we think about what motivates people to, when they're in the market for a new car, what motivates them to buy a battery electric vehicle rather than a conventional gasoline powered vehicle? So obviously there are many, many dimensions, many factors here. I'm not listing all of them, but just a selection here. Obviously, vehicle technologies, the available models, the capability of the vehicles, the range of the vehicles, that plays a big part, as does the pricing. Pricing is connected to policies and incentives. The federal government provides incentives to purchasing electric vehicles. Now, when we talk about vehicle range, the availability of chargers, both at home and publicly, plays a role. The marketing plays a role. How are they being marketed to potential drivers? And a range of psychological factors. So there's something that we call range anxiety, which is concern about running out of range. That's something that's been investigated pretty widely. Now, there's one more point here, and this actually brings me to the research that we conducted, which is what exactly is the environmental benefit of driving a battery electric vehicle? Now, as a consumer, if you know that, how would that affect your decision to adopt? So what we're really getting at here is our indirect emissions. Because charging a battery electric vehicle, it consumes energy, right? And that energy has to be produced somehow. And so the production of that energy might be associated with emissions. So even if my vehicle does not generate tailpipe emissions by driving it, there still are potentially indirect emissions because of how the power was generated. So down here on the right-hand side, we have a picture of a coal power plant, right? And so this obviously is would be a major producer of carbon dioxide from fossil sources. And if you drive your BEV that has been charged with power generated by this power plant, then indirectly your BEV is responsible for some of the emissions generated by this coal power plant. Now, we have, in the US, we have large regional differences in energy production mix. Some states draw a lot more energy from fossil fuels than others. And so the research question that we asked here was how the decision to adopt a battery electric vehicle is affected by these differences in regional energy production mixes, and whether it is at all. And if so, how much people are actually willing to pay to reduce their carbon emissions from driving. So let's look briefly at what these emissions actually tend to be. Excuse me. So a conventional gasoline vehicle, driven the average distance that Americans drive cars, usually emits about 11,500 pounds of CO2 equivalent per year. Now, we're saying CO2 equivalent because not all the emissions happen in CO2. Gasoline production, for instance, also tends to emit other types of compounds like methane that also have climate change implications. For the purposes of comparing stuff, we translate everything to equivalent CO2 emissions. So about 11,500 pounds of CO2 is what we're looking at with a conventional combustion engine vehicle. Now, hybrid vehicles have been on the market for a long time. The most common one that started, I think, about 20 years ago was the Toyota Prius. On average, a hybrid electric vehicle, which does have a combustion engine on board, emits about 6,200 pounds per year. So not quite, but close to half of what the combustion engine vehicle does. Now, if we look at battery electric vehicles, this clearly varies by energy production mix. So the national average of driving emissions due to driving a battery electric vehicle are 4,300 pounds of CO2 equivalent, which, as you can see, is actually not that much below the hybrid. And it depends on the regional energy production mix. So in Ohio, given how power tends to be produced in Ohio and what the share is of fossil fuels, as a matter of fact, the battery electric vehicle is very, very close to the hybrid vehicle in terms of the emissions generated. Contrast this with California, which takes a lot more of its power from renewable sources. I don't know off the bat whether nuclear power also has a larger share in California. But in California, it's about a third of that, 2,155 pounds of CO2 equivalent. Meanwhile, in Kentucky, as an example, driving a battery electric vehicle is actually worse for the environment than driving a hybrid. And again, this is due to a large share of coal in the production of energy. There's also something called a plug-in hybrid. This is a hybrid vehicle that you can plug in, charge the battery. We're not going to talk much more about these, but here it would vary by energy production mix. It's always going to be somewhere between the battery electric and the conventional gasoline vehicle, or probably more between that and the hybrid vehicle. So here again, we designed a survey. As a travel behavior researcher, a lot of my research is survey-based. But this time it was actually a nationwide survey. So we were not focused on one specific location like the medical center. We conducted an online survey. We recruited 1,657 individuals in 5 major cities to respond to this survey. The 5 cities were Columbus, Cincinnati, Cleveland. And then for comparability, we also added 2 more major metro areas outside of Ohio, namely Atlanta and Los Angeles. And it was a large survey. It had many different components. So what I'm talking about here is one specific component of this survey, which was, again, a choice experiment. So we asked people to imagine that they were in the market for a new sedan. And they had to choose between a conventional vehicle, a hybrid vehicle, or a battery electric vehicle. So the screenshot over here shows this choice experiment. We had fewer attributes that were shown to people just to limit the amount of mental processing they had to do than in the microtransit survey before. But we had more options here. So we have a hybrid, we have a battery electric vehicle, and a gasoline vehicle. Each one has a purchase price, it has fuel costs shown, and then it has carbon emissions per year. Other than the things shown, people were asked to assume that the technical capabilities of these vehicles are generally comparable, the same body type, same size. So we're trying to take everything else out of the equation. There's an opt-out option over here. Even if these were my best options, I would not choose any of these vehicles. So here again, we varied the attributes in order to understand what the trade-offs are that people make. The costs are shown here. They were on 4 levels, somewhere between $15,000 and $40,000 for the new car. And then the fuel costs for the combustion engine vehicle, ICE stands for internal combustion engine, and the hybrid vehicle, these of course reflect gasoline costs. For the battery electric vehicle, it reflects the cost of electricity to charge the car. So we varied these across these experiments, and then also we showed people the carbon dioxide equivalent emissions rounded to the nearest 1,000 of the 3 car types. Now, we really want to focus on emissions here. So all the participants went through several scenarios, and the first ones were as shown in the screenshot above. I'll go back here. The battery electric vehicle had these carbon emissions that were equivalent to the national average, 4,000 pounds a year, which makes it the lowest emissions option. So that's the average option, right? And then people got randomly sorted into a high or low emissions scenario, and it was introduced as shown down here. Suppose that a new low-cost technology is widely adopted, increases the amount of electricity your region gets from. Now, in this example, we said from fossil fuels. We also, in another example, we said from renewable energy. The carbon dioxide emissions for the battery electric vehicle are now, in this case, higher and are about 8,000 pounds a year. The others remain unchanged. So people randomly went down one of these branches, the low emissions or the high emissions branch. In the low emissions scenario, their battery electric vehicle dropped to 2,000 pounds a year. In the high emissions scenario, it became 8,000 pounds a year. So what did we see looking at this? First of all, again, pretty significant interest. So a considerable number of respondents actually chose the battery electric vehicle. If we look at the average emissions scenario here in the middle column, we can see that the battery electric vehicle was actually chosen the most out of these options. 36.5% said, given these 3 options, I would want the battery electric vehicle. So obviously, these kinds of choices can be heavily affected by the hypothetical nature of the experiment, but nonetheless, it clearly is an indication of the high interest among the people that we were surveying here. And it allowed us to understand the trade-offs, the things that drive this interest and that can increase or decrease someone's interest in adopting an electric vehicle. So how did we analyze this? And by the way, I should note, sorry, one more thing, which is look at the hybrid and battery electric vehicle shares. So we see this sensitivity to the emissions very clearly. If you look at the average scenario, 33.9% hybrid, 36.5% battery electric vehicle. If we go to the low emission scenario and we're reducing the emissions of the battery electric car due to power generation, more people are choosing it. If we increase the emissions of the battery electric vehicle, fewer people are choosing it. It was not evident upfront that there would really be such a big effect. So our number one insight here, we're going to come back to talking about this more, is people really are reacting to the indirect emissions due to charging their battery electric vehicle. So we analyze this again with a discrete choice model, a statistical model that allows us to understand these trade-offs. Not only that, but it also allows us to quantify and calculate willingness to pay. And the willingness to pay that we're looking at here is, you have a combustion engine vehicle. I'm going to offer you a battery electric vehicle that has much fewer emissions, lower emissions than your combustion engine vehicle. What is the premium that you are willing to pay, all else equal, in order to reduce those emissions of yours? So if we look at these willingness to pay figures here, on average, we find that people were willing to pay $6,700 more, all else equal, in order to reduce their emissions with a battery electric vehicle versus a combustion engine car. In the low emission scenario, that further increases, $9,500. Now, interestingly, remember how I said in the high emission scenario, the BEV became much worse. And so actually the emissions of the electric car in the high emission scenario became greater than the hybrid. And lo and behold, we can actually see a reversal of this willingness to pay. All of a sudden, and this is again very clearly showing how people are reacting to the emissions of their electric car, we can see that all of a sudden they are willing to pay much more for the hybrid vehicle than for the battery electric vehicle when the emissions of the battery electric vehicle are greater. Now, these are average numbers I'm showing here. There was, of course, there were variations regionally, right? And if we looked at people's willingness to pay, respondents in Los Angeles were on average willing to pay a lot more to reduce their emissions than the rest of the group. This was followed by Atlanta, which was somewhere in between. And our respondents in Ohio were actually the least willing to pay an additional premium on a battery electric vehicle compared to a combustion engine vehicle. So what are we taking away from this? Well, first of all, just developing these kinds of, getting these kinds of analyses and developing these kinds of models is very valuable from a policy perspective, because it actually allows us to better predict future battery electric vehicle adoption rates at a regional level, given the policies, for example, that the Biden administration is currently pushing. And it allows us to uncover previously unrecognized factors that might affect or hold back electric vehicle adoption. And so one such factor is what we were just talking about, the fact that emissions, the indirect emissions from power generation really matter. Now, on average, the premium that people were willing to pay, it depends on the amount of emissions reduction, but it comes down to about $200 per metric ton of CO2. That is actually comparatively quite a lot. So it is much higher than what's currently being used for policy analysis by the US federal government. And that is very important, because that's how the federal government, for instance, determines what sorts of policies or infrastructure is worth investing in. They have to quantify the benefits, and the benefits that they're using, the numbers they're using to quantify those benefits at the moment, actually put this number somewhere around $50 per metric ton. We're finding that in the population that we surveyed, that willingness to pay is much higher. So in other words, our population that we surveyed is perceiving much greater benefits than the federal government is reflecting in their policy analysis. And then the final thing that I want to mention, the last point, is that this really also brings us to the question of what are the true costs and benefits of investment in various power generation technologies, right? So large parts of our country are still very reliant on fossil fuels, and overall fossil fuels for power generation. And I think off the top of my head, the share of renewables in Ohio, I think we're still actually fairly close to 80 to 90% fossil fuel sources for power generation. So now what we're finding here is actually a further reliance on fossil fuels for power production might indirectly be holding back electric vehicle adoption, because people don't really see a benefit in adopting electric vehicles. And remember the numbers I showed for Ohio beforehand that showed that actually with the regional energy production mix here in Ohio, driving your electric car is not going to be much better than driving a hybrid. But we're finding, yeah, this really matters also for people's willingness to buy electric cars. But conversely, and this is the really interesting point I think that comes out of this, is that if we were to invest in renewable energy production, then we would not only be reducing the emissions from power generation, so the direct emissions from removing, say, coal-fired power plants from the grid, but we would even have indirect benefits, because doing that could promote electric vehicle adoption. And so indirectly, that investment, it would pay off twice by not only reducing the emissions from the power plants, but also leading to emissions from traffic due to reduced tailpipe emissions because of people being more willing to adopt electric vehicles. Okay, so that is all I have for today. Thank you very much for your interest in this presentation. Now, unfortunately, we are actually fairly close to to 1 o'clock, but Kevin, do we have time for some questions? How is it looking?
Yeah, I think we have a few minutes for questions. Yeah.
So I think with the size of our group today, please just go ahead and raise your hand and Andre can get them, or if you would like, you can add it into the chat.
We see a question in the chat.
Yeah, so there's a question in the chat of what about the supply of microtransit services and just using your example from the Ohio State Wexner Medical Center, would it be operationally feasible to sustain a microtransit vehicle use at the level given the geographic distribution of those employees?
That's a good question. So this is getting at the operational and planning question. So directly, I cannot answer it because I haven't looked at the supply side yet at this point. That is a future plan for research. But what I do know in general, the geographic distribution of OSU Medical Center employees, it really differs by employee group. So for certain employee groups tend to live in Columbus much more than others. I'm thinking, for example, of the nurse population at the Wexner Medical Center, where nurses tend to work 3 days a week. I think it's 3 times 12-hour shifts, if I'm not mistaken. And so therefore, actually a fairly large number of nurses commutes from well outside of Columbus. And they will spend the 3 days here working, and then they go back to more rural parts of Ohio. And so for those types of commute patterns, I think it would be very difficult to sustain a microtransit service. So really, it would be, I think, much more limited to employees living in the Columbus area, which is still a sizable number given the size of the institution, the medical center. Now, I'll say anecdotally, based on my knowledge of the cost of providing microtransit service, I am relatively skeptical that such a service can really fully cover its costs. I think if we're talking about economic sustainability, without wanting to name numbers, I believe that it's fairly unlikely a cost can fully cover its services. So that really comes back to a policy question for the employer regarding at what level they're willing to subsidize it as a benefit to their employees. But I think in determining this, one should also certainly consider the savings from not having to provide parking spaces, not having to pay for the land that parking garages sit on, not having to pay for park and ride services and all the other, everything else that goes with actually providing parking, which currently is provided, well, not free. There's a cost to the permits, but there's still a major cost that the university is absorbing. Okay, I see another question here. In the BEV study, was the range held constant and the same across the 3 vehicle alternatives? Well, that's tricky because, of course, we don't tend to think of range when it comes to the conventional vehicles and hybrid vehicles, right? So with BEVs, yes, we do tend to think about range a lot. That is one of the variables that was not included here. So we did not talk to people specifically about range. We told them to assume everything else was equal, but this was, in a sense, silent. And so that does, of course, introduce a few limitations in terms of how we can interpret the results coming out of it. Those are nuances that I didn't get into in the context of this presentation. But obviously, yes, the range and the perception of range is an unobserved factor here. Now, we did also, to some extent, that might add some realism because people had to assume the range that they typically would assume of a battery electric vehicle without us telling them. And we did actually, in separate parts, in another part of the survey, we did actually ask them about their perceived range. So we did actually collect that information. We didn't state it, but we asked them what they thought the range of an electric vehicle was. So we did have some information to control for this.
Are there any other questions?
How are we
Well,
doing on?
well, we're pretty much at the end of our time right now. So I wanted to thank you, Andre, for being able to share these relevant results and some interesting and
Thank you.
different thinking about how we travel about, and particularly in the context of that daily needs to get to our workplace. So I very much appreciate that. And I would like to thank everyone else who was able to take some time from their lunch hour to join us today. We hope that you will be back with us at our next CEGE CONNEXT event, which will be February the 8th. And we'll learn a little bit more about improvements to the safety of our water systems at that presentation. So take care to everyone.
Thank you, everyone.